Good day, folks. Let's look at the exam question. This is the Doppler Effect question, and let's cut the chase. It says a siren of a police car produces a sound of frequency of 420. This is the frequency of the source as produced by the police car. A man sitting next to the road. That's very important. Sitting next to the road, that means that the listener is stationary, right? It's not moving. Notices that the pitch of the sound changes as the car moves towards and then away from him. So you observed the change, right? So it says write down the name of the above phenomena. This phenomena is the Doppler Effect. That's the name of that formula, that observed change frequency. Now 7.2, it says assume that the speed of the sound in the air is 340. So 340, this is the V, velocity of sound, and calculate the frequency of the sound of the siren observed by the man. So we want the velocity of the frequency of the listener when the car is moving towards. It's very important, this statement, towards, right, at a speed of what? Of 16. This is the velocity of the source. So now in 7.2, so we want the question, we want the frequency of the listener. What do we have? The velocity of the source is what? Is 16 meter per second, and it's moving towards him. And then we have V, the velocity of the sound in the air is 340 meter per second. And we're given the frequency of the sound. The frequency of the source, which is, it was 420 hertz, right? And then guys, we're told to calculate while it's moving where? Towards him. So towards, it's going to be plus divided by minus. So let's write the formula. The formula, it will be frequency of the listener is equal to V plus minus V L divided by V plus minus V source multiplied by the frequency of the source. And then now, since we know it's towards, this is towards, guys. When we talk about towards, it's this. Check my previous video. It's going to be plus V L divided by V minus Vs times by frequency. Right, let's substitute now. We want the frequency of the listener. We were given the velocity of the speed of the sound in the air. It's going to be plus the velocity of the listener. The velocity of the listener, it's 0. Velocity of the listener, it was 0. And then same velocity, 340 there, and minus the velocity of the source is 16. And then we multiply by this frequency of the source, it's 420. So if you punch that in the calculator, it will give you 420,74 hertz. Right, that's how you calculate the frequency of the listener when it's moving towards. Now, the question now, it says the police car moves away from the man at a constant speed and then slows down and come to rest. It moves away and then slows down and come to rest. Now it says in 7.3.1, how will the observed frequency compared with an original, which is the original is the one that we just calculated. With an original frequency of the siren when the police car moves away with the man at a constant speed, right, greater or equal to or smaller. So guys, the frequency is going to be smaller while it's moving away. We are told it's moving away. While it's moving away, the observed frequency, it's going to be what? Smaller. So the answer here is what? It's smaller then, because it's moving away. Remember, if it's moving away, the frequency of the listener is lesser than the frequency of the source, right? Now, how will the observed frequency change as the car slows down while it's moving away, guys, if the car slows down while it's moving away, instead of the frequency to be lesser, the frequency of the listener to be lesser than the frequency of the source, it's going to be greater. So the change, the observed change there, now it says how will the observed frequency when it slows down? So the observed frequency is going to increase, guys. So the answer here, it's increase, because the frequency of the listener while it's moving away and it slows down, it's greater than the frequency of the source. That's always the case, guys. I hope this exercise, guys, it gives you a better understanding of the topic. Cheers, bye.